Hey everybody, this is Larry. This is day 7 of the Leetcode Daily April Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Last stone weight. I have a 736-day streak going. You can't see, I need to figure out how to change my camera because that's where my face is where the streak kind of is appearing apparently. But yeah, oh well. Anyway, today's hope everyone's having a great Wednesday and all that stuff. Yeah, let's get started. So okay, so you're given an advantage of stones where stones of eye is the weight of the eye stone. Okay. On each turn, choose the two heaviest stone and smash them together. Okay, so then now and then the stone has the weight of either they both destroyed or the leftover. Okay, and then put it back. Okay. Given that n is equal to 30, first thing, wow, only 30, that's interesting. The first thing I would do is just keep doing it. Just simulation. I mean, the first thing I would think about is like what they tell you what you want to do, right? So what would it take if we simulated, right? So a very naive way of doing it is just looking for a for loop. You know that every time, so there's n elements, right? Every time you run with one simulation, you have either n minus 1 element left or n minus 2 element left. So that means that if you do a simulation, then this is going to be n squared. And given that n is equal to 30, this is going to be pretty, fast enough. I don't know why n is so small, but at least that's way, and that's if you do it very naively, right? Of keeping track of two heaviest stone in a loop or something. Of course, you can optimize it with using a heap or something like that because, as you can see, you're getting the two heaviest stone every time. So yeah, so let's kind of do that. And given that, even if we do the naive one, it's going to be n squared, and if we do it with a heap or something like or a priority queue, it's going to be n log n as a result. Given that n is equal to 30, that should be way fast enough. Yeah, I wonder if there's some like funky math that you can do to do it in linear time. I would guess maybe not, only because you would have to sort anyway. Maybe. I think you have to sort anyway, but I could be wrong about that one. Let me know if there's any like, funky up south type thing. I mean, maybe there's some like weird math parody things, but I don't know. I'm not gonna lie, I don't know this one with respect to that. So yeah, so let's do it with heap and let's get started. Remember that the Python heap queue library is kind of a little bit weird to use. I'm not gonna lie, I wish that it passes like a key thing. Let me see if I can learn. Just let me look at heap queue in Python to see if I can pass a queue. Oh, so there is a key type thing. Okay, so actually, okay, that's wait, let me make sure that I'm right. Help heap push. Nope, that doesn't help. Oh, so there's an n largest and n smallest that takes a and merge, but but I think I've been looking at this not that long ago, but I thought that there's a way to do it with a key function, but it seems like now you have to write like okay, you have to write an ordering class or a data class for that. So yeah, I mean, and of course, if you have infinite time, or maybe not infinite time, just a little bit more time, that's what you would do. But yeah, I'm just gonna do it that way. So yeah, so now for extant stones, and of course you can actually use heapify for this, but that's fine. I like doing it this way. So then we put everything in a heap. But of course, in Python, the heap is a min heap, and we want a max heap to get the two heaviest stone, right? So let's actually have a helper here. let's say x, then now heap q dot heap push heap of negative x. And the logic we have here is that, you know, to get them to convert a max heap, or sorry, a min heap to a max heap, you just take the negative of the number, because, you know, the smallest is the max and so forth. Once you multiply by -1, but it's a little bit awkward. But if you haven't seen it before, but if you have seen it before, or you know, you just get used to it. That said, still not great though, if you ask me, but it is what it is for now. Because it is definitely not as clean as defining and ordering on something. Okay, so now while length of heap is greater than 1, yeah, because there should be at most one stone left. I mean, they tell you that, but you can also prove that yourself. So then now we just take 2 stones, right? Stone is equal to pop, let's say, and we can define that as well as a helper. Remember that this is the negative of that, so that's why. And now we just want to push absolute of x minus y. This is the same. Oh, well, I was gonna say this is the same as this, which is true, but not if not in the both this case thing. So okay, so or if x is not equal to y, we pop it. Okay, and then now at the very end, we just have to make sure if we have no items left, we return 0. Otherwise, we return the last item left. Maybe return the pop version of that, so we can kind of keep it clean a little bit. Let's give it a spin. Okay, so that looks good. I think we can probably just like put in random numbers or something, but okay. I mean, this code is simple enough that it should be good. So let's give it a submit. Hopefully this is good. Apparently I've done it twice before. I mean, this is just straight up simulation, so I can't really, I mean, other than missing some like edge cases like n is equal to 0 or something like that. Not to say that this is wrong on that case, but it could be. This should be, yeah. So again, this loop will happen over n times iterations, and each of these iterations will take all of log n cores, though this actually gets smaller as it gets whatever. So yeah, so this is going to be n log n time and linear space for the heap. That's pretty much all I have for this one. Yeah, let me know what you think. Stay good, stay healthy, to good mental health. Hope y'all have a great rest of the week. It's coming up to be a little bit rainy here in New York. Hopefully it stays okay. And oh, it's on your haircut now that I see a little bit. But anyway, I'll see you later. Take care. Bye bye.